Hi everyone, we're going to sketch the graph of this polynomial f of x, and let's fill out some information. The first thing we notice, it's not in standard form, so let's determine our degree. If you look at your multiplicities here, we have 2 plus 1 plus 2, so our degree is just going to be 5. What you need to know about your end behavior is that 5 is an odd number, and we also need to know that our lead coefficient is positive. We're going to get back to this in a moment. Now let's look at our x or y-intercept. That is when x is 0. So just plug in 0 here. You get 0 squared times negative 2 times 1 squared, and that equals 0. Now let's look at our zeros. That just means your y is 0. So make that 0. And so this could be a 0. And 2 minus 2 is 0. And negative 1 plus 1 is 0. So here are you have 3 zeros here. So we have 0, comma 0. We have 2, comma 0. And we have negative 1, comma 0. The maximum turning points is n minus 1, which is 5 minus 1, which equals 4. And this part here, we're going to do this after we graph. Where is y negative and where is our graph positive? All right, so now we're going to go back to our end behavior. So let's look at that. We have an odd number and it's positive. So we're in this area right in here. So right in this box in here. So in our case, our degree is 5. And it's still positive, so our graph compares as y equals x to the 5th, which is very similar to that. You still go here. The only difference is it's flatter in here, and then it shoots up faster. So it's flatter, and then it shoots down faster. So anyway, we don't care about that so much. We care about our end behavior. So when we graph, we know we're going to start in quadrant 3 and end in quadrant 1. And quadrant 1 is positive, positive, and quadrant 3 is negative, negative. So this means as x from 0 gets larger and larger, so does my y. This portion here. So does my y. All right, as x gets smaller and smaller from 0, so does my y. All right, so that's basically what that means. If you look at this, we have positive, positive, so that's quadrant 1. We have negative, negative, that's quadrant 3. All right, now let's graph this. So our y and x-intercept is 0. Then we have 2 and negative 1. Now we're going to look at these multiplicities here. We know we're starting in quadrant 3, and we're supposed to end somewhere in quadrant 1. So what we're going to do is we're going to go up to this negative 1. Well, this portion has to do with this piece, this factor. It's an even multiplicity. That means we cannot cross the x-axis. So you're going to swoop down. We don't care about our min and max. So you just make a U-turn and go back up to 0. So that's this portion. That's where you got the 0. That's also a multiplicity of 2. So you can't cross. So let's go back down and then go up to 2. Let me write these. 0, negative 1. So at 2, our multiplicity is 1. That means we can't cross. So there's your graph right there. All right, and again, we're not going to care about the exact values for this on this video. Now, let's look at our turning points. We have 1, 2, 3, 4. So we had exactly 4 turning points of this graph. Now we want to look at where our y, here's y is equal to 0. So where is our y positive, and down below the graph, where's our graph here negative, our y negative? So when you look at this, the positive part. Where is our f of x positive? Well, it's positive right here, from 2 to infinity, looking at your x values. Now, where is my graph of f of x negative? And that falls below this line. So it's this whole piece here. That's all below the y equals 0. So that's going to be from negative infinity to 2. And that's all. Thank you. Have a nice day. Bye-bye.